Sometimes you come across a genuine question that when people ask you that what is the importance of this research, what is the importance of this area of specialization. So today I'm going to talk about briefly in just 2 minutes that what is the significance of our area of research. So have you ever wondered how water flows in a river? What is the pattern? What is the physics behind this flow? Or how the wind goes across the aircraft? Or even, for example, how the blood flows inside our bodies. At the heart of all these phenomena, there is one set of equations, and that beautiful set of equations is called Navier-Stokes equations. Navier-Stokes equations are the set of fundamental equations that describe how the fluid flows. So in other words, you can say that the Navier-Stokes equations are the second law of Newton, but for fluids, of course. For example, imagine how a drop of ink spreads in water. So physically, these equations, they just balance all the forces. For example, the viscous dissipation, the pressure force, the gravitational force, of course, and any other external force which is applied on the scenario of the fluid flow. Set of governing equations in terms of partial differential equations describe how the fluid behaves. The question comes in mind, why these equations are important? The answer is very simple, because these equations are required in every field of the science. For example, engineers use them to design innovative ideas, to design innovative aircrafts, efficient machines, efficient pipelines. And in medicine, this set of equations is used to study the behavior of the blood flow and to develop treatment for the heart diseases, for example. Despite their importance in all the areas of science, it is not easy to solve the Navier-Stokes equations, especially when you are dealing with the complex flows, when you are dealing with the three-dimensional geometries. And the Navier-Stokes equations are the backbone, mathematical backbone of fluid mechanics. And without these equations, you cannot think of modeling the real world challenges of the fluid mechanics. The final word is that these equations help us to design, to innovate across the science and engineering. And this set of equations is an example that how powerful mathematics is in all the areas of science. In the coming videos, I will try to discuss terms of the Navier-Stokes equations and their physical significance.